Okay, now the topic is series. As usual, we are going to first go through what the syllabus wants us to know. What the syllabus wants us to know as far as the topic is concerned. Now you can realize that as far as the syllabus is concerned, it is the very first topic of Senior 5 Term 3, and it is topic 13. Because topic 12 is permutations and combinations, something we shall cover next holiday. You don't need that as urgent as this early. So this topic basically has 4 subtopics. Yeah, it has arithmetic progression, and geometric progression. This one is usually abbreviated as AP, and that's what I'll also be saying. Then this one is basically abbreviated as GP. You get? Yeah. Then there are the other two, that is proof by induction and binomial theorem. But in the old curriculum, it was only proof by induction that was part. The binomial theorem was somewhere else, but this time around they put it under the topic. But basically for today, proof by induction, it will depend, but we may do it next holiday or during term 3 so that people find it ready when they come back, but it will depend. So basically today I want us to leave this session when we have clear concepts on arithmetic progressions and geometric progressions. Basically, you realize the very first learning outcome that is supposed to be unpacked is how series that are progressing arithmetically should look like, and how series progressing geometrically should be maybe represented. Something like that as well. But we are going to follow our pace. And as you can see, among the project work that they expect you to hand in or submit immediately after registration is concerning this very topic. So you need to understand the basics so that project work doesn't really give you a time. And the moment you play with project work, you are affecting your overall result. So you gotta be serious about the project work. Yeah. We shall maybe come back later to read through these ones, because as of now they may not make sense because of the words there. I'm seeing common difference. I'm seeing even the word series, which is not okay. I'm seeing there are some of an AP, nth term. So the learning outcomes are full of unfamiliar terms. So I may not read through them right now, but rather introduce the topic. Maybe later on we shall come back and see what we've not talked about and what we've talked about. Basically that. Yeah. Now, to give you a local introduction about the topic, basically, I'll take you back to primary. I'll take you back to primary. How? They used to give you such questions and they said, question, let me just say, complete the sequence. I'm going to put here sequences. I'm going to put only 3 to save time. Put here 1, put here that, I'll put here 4. Hmm. So you people should start writing those two numbers that are missing in the chart so that we save time. Please, Lubega, promise you leave our screen. You remove that yellow line you put. You should also tell me those ones missing there. And lastly, you should also talk about these. Let me see what people are writing in the chat. People, I'm waiting for those answers. You write part A, you write those two. Part B, you write those two. Even part C, you write those two. This is very important before I introduce the topic. So take it serious. Yeah, people are doing the needful, and so far the comments are right. I now want to see part C. Part C. People have overpassed A and B. Part C. If you can unmute and speak, the better. Yes, this is supposed to be interactive and not just tutor-centered. People, part C. Anyone part C? I don't know why some of my friends have been quiet. I don't know. Maybe people studied from home. So those two people passed because according to the numbers that were written before, we were multiplying by 2 by 2 by 2. Then this second one, if I'm to realize, plus 4 plus 4 plus 4, that is 23, plus 4, that is 27. People passed that one too. So it's this last one that was a bit sensitive, but of course not so sensitive, but it was most important. It was plus 1 times 5, again plus 1, then times 5, again plus 1, times 5. So here you had to add 1, get 156, then multiply by 5. You get? Then you get 708. So those two are right. Now, what is important about this is that these numbers were following a certain order. So just like you can see this word, this, it is sequencing. Sequence is just there to show you that these numbers were following a certain what? A certain order. Which order you used to find it your own as a student. So these were sequences. Those who recall your primary very well, they never mentioned the word series anywhere. So these were just sequences. So someone may be like, how do sequences differ from series? Now I'll bring the very first and tell you the very first good news that we can never have such in series. Yeah. Such orders never happen in series. That is one. Then two, commas are not used in series. Commas, those commas you see, the ones that are separating numbers, are not used in series. So say bye-bye to the commas. So they are not used in what? They are not used in series. So before I even begin on one part of the series, I'm going to maybe begin with which orders are really used, and then maybe I later bring on if commas are not used, then what do we use? So after talking of those differences, I'll pose question 1 and say, which orders are used? And we shall have our answer. So this is the answer that is going to make sure you master this topic from its roots. So which orders are really used? So the orders that is, I don't want this word to confuse you. The orders, I mean these things we're adding, multiplying. This is what I mean by the orders. Like the order we are following to add on more terms and more terms and more terms. So I'm like, in series, In series, a common term is always subtracted or added or added but not any two or both at once, so I can say in the same series. So I want you people to learn that. That we never and never, provided we are dealing with a common term. That's what we call a series. Provided it is a common term. So I was saying that provided the term we are adding is common and non-changing. By common term, they mean if you decide to add 4, please add 4. If you're deciding that I'm subtracting 3, please subtract 3. Not like this last order we had. That last order we had, at one point we added 1. At some other point we multiplied by 5. There are longer series that may even have all the 4 operations, which is not wise. For something to be called a series, it should strictly be a common term. If you're multiplying and you've agreed we are multiplying by 10, let it be 10 and let it be multiplication. If you've decided that we are dividing by 5, please multiply by 5 throughout. Let it be dividing throughout and let it be throughout. Let it be 5, let it be division. That's why they call a series. So a series doesn't have anything like we are adding, again subtracting, again never. A series does not have a 2, a 5, a 10, no. One common term and we are doing the same thing. If it is subtracting throughout, if it is adding throughout, the moment you're given a question and what you're dividing throughout changes at some point, it ceases to be a series, it's now a sequence. Because it's just a sequence of just a sequence. Then if we don't use commas, what do we actually use? So after us confirming that maybe we are adding the same thing throughout, a case in point, let me show you this. When I have my 2 here, my 4 here, my 8 here, my 16 here, you people realize that it's times 2, times 2, and times 2. You understand? So this times 2 as a common term. It's what I was calling a common term. Why? Throughout we are multiplying, throughout we are using 2. Throughout we are multiplying, throughout we are multiplying by 2. You get? Same operation, same figure. So this one becomes a series. So this one is a perfect. It's not even a perfect one because we still have commas there. So I'm going to say perfect series. So it can just be a perfect series. After all, we are dealing with a common term. So, how do we make it perfect? Commas should not appear. So, how is it supposed to be written? So, this is the right writing. Remember, they do this and put dashes to show that there are some other terms. So, if it's going to be a series, what we do, we set 2 plus 4 plus 8 plus 16 plus, that's what they call a series. Yeah. We should be dealing with a common term, and instead of commas, we use this. Plus, plus, plus. Whether the common term is being divided, whether the common term is being multiplied, we don't care. Instead of commas, that's what we use. I hope it makes sense. The other one that we had, I think it was a plus 4. So now this one is the perfect. Yeah. That's the real series. That's how they should look like. Then like there is the other one. Let me call this A. So we had the other one, B of plus 4, where I had 3, 15, I think 19, comma, like that. They usually put 3 dashes, the one they call the ellipse in English. So here we are adding 4 plus 4 plus 4 plus 4. Let me put all of them down. So realize now this plus 4 throughout. Throughout, we are adding. Throughout, it is number 4 and not any other number. So that's what makes it a common term. At this point, when it's still having commas, we call it a what? A sequence. But it can be a perfect series because of the common term being added throughout. So if we really want it to look good, we just bring in our commas. Like this is 3 plus 7 plus 1 plus 11, sorry, plus 15 plus 19. We put a plus, then the 3 dashes. You get? Now this one is a series. Now this one, the first one, it is always called the first term. Those who I taught polynomials this very holiday, polynomials was our very first lesson. We agreed, we talked of these things of terms. So the word term is back. So the first term of the series, yeah. So even this K2, someone can call it that one. Someone can call it the first term of the series because it is coming first. But we are going to look at the very serious examples. So here, what I really wanted is you people to stop that thing of using commas and understand that we are going to be using the plus. Then understand the moment things are weird and in the same sequence we are subtracting and in the same sequence we are adding, that cannot be a series because we don't have a common term we are dealing with. That is all. For you to call something a series, make sure throughout you are dividing or multiplying or adding or subtracting, but not any of the two acting at once. If you have decided to deal with the figure 5, let it be 5 throughout. If somewhere the figure changes from 5 to 4, that is a sequence and not a series. Okay, now, I want you to look here. I want you to look here. You look at this series, eh? Now we are going to the classification. So we are going to bring it in terms of sample series. You look at this. We are having 10, 8, 6, 4. Let me stop there. Here, let me begin with 12. You tell me those next three numbers. Tell me the numbers coming next on A and B very fast. Okay, all of you have passed this. Okay. So you have said 2 here, 0 here, then -2. Most of you have passed this. But I just want us to learn something. So you people, this is what I want to ask. This thing that people add, yeah? Okay, what I really want to know. I don't want you to lie. How did you people come up with these two? Did you say 12 minus 10? I don't want you to look at the negative. Yeah? The -2 came later. The -2 came later. But I want you people to tell me the fact. When you're dealing with this series, like this one, these two, what do you always consider? We always have, let me do it like this. We always have this beginning term. Let me put here A, then B. You get the point? Then we always also have this beginning term, that one. I want you people to be honest. Don't lie to me. Don't even focus on what we have here down. I don't want any of you to focus on this Please don't focus on that. But I'm asking something open. We have those two terms A and B. How do we always get this thing? Do you people do, let me put for you here options A and B. Don't lie, be honest. As you people try to find out which term is commonly being added or subtracted, do you always get A and say A minus B? Or you get B and say minus A? What do you always do? Before you come up by saying, they were subtracting throughout or adding throughout, I'm talking of that figure 2. It could be 4, it could be 3, but I'm asking, what do you always have in your brain? Do you always do B minus A or A minus B? Let's see if people are honest. Don't lie. Thank you for being honest. You always say A. You always do this. You always do this. So this one is out. You understand? Even this B minus A, it's the one working here. You understand? Hey, that is nice. This is nice. Now, let me consider this second one. 8 to 10. Now, we said this one was the first term. Now, who can tell me how to call this without calling it the second term? Who can tell me the name of the 4 without calling it the second term? Hey, you people are not easy. You people, let me ask you. Let me ask you something. You people have been, you've been in families. You've been in families. Um, Especially the Baganda. The problem with Baganda, you only know these things in vernacular. But let me ask. Let me ask something. Um, Before let me not even go to the family thing. What name is given to that person who comes after who? Oh, okay. In case someone dies, what name is given to that person who comes? Sorry, someone had called. I was saying that in case someone dies, what name is given to that person who comes up and maybe they take up their roles? That's the name I want. Eh, banai. Eh. These things of hairs are things that There are things of property. Someone who is going to take charge. That's what I wanted. Now someone is telling us in Kiswahili. Thanks, Hilda. I wanted the word successor. That's the word I wanted. That's the word I wanted. So in English, someone that comes after you is always called a successor. Then what name is given to that person who comes before you? Maybe now people can get it. You see this series, we are going to read the introduction together, and there are words that are going to disturb us. It's what I'm trying to fight. You people are in families. If you're the firstborn, there is that person they produce next. What name is given to that sibling? You are what? The problem, you people don't speak English at your homes. The Baganda say, ono yakuddako, gwo omuddako. That's all they say. But tell them to speak English. That's where problems arise. You people tell me, that person who is... But you people play a lot. You people, if you're 9 years... Okay, let me do my thing. Okay. So, this is our first term, and this is the term that comes after the first term. So that one becomes, I can, a succeeding term. You get? Succeeding terms because of those things of successors, as you've said. But now, you people, what if I just extract out this thing, the 6, 8, and I put it here. And then I choose this term as my random term. Let me put it here on the next screen. So we have 6, 8, and 10. This is what I want you to learn. 6, 8, and 10. So I'm choosing 8. As my random term. We have said this term that usually comes after any term you've chosen, it's like a successor because it is coming after. So we are calling it the succeeding term. Then how do I call this? That's the word I wanted. This one that is below our random term. In simple terms, what is the opposite of succeeding? Should we call it the succeeding or proceeding term? Exactly. Exactly. People are very good. Succeeding, though the word proceeding is not so common, yeah? The common word is succeeding, but proceeding, coming after. So this one is called the preceding term. That's what I wanted. This is the word I wanted, yeah? Preceding term. It is so common even in questions, yeah? But I didn't want to just put it. The problem with putting this word preceding term, people may mistake it for the succeeding term. So I always bring it after talking about the other succeeding term. But also this word pre can help you to understand that pre means before. You get it? Pre is for before. So the moment I say that term, don't be confused. So I want you people to agree. If you agree, I'll tick that box. So do you agree with me that as we check for the common term that is added or subtracted, multiplied or divided, do people agree with me that we always do people agree with me that we always get any term, then subtract the preceding term? At least you leave the lesson when you've learned that the opposite of succeeding is preceding. Succeeding, double E, preceding, single E. At least today you learn the English, you leave the mathematics. Yeah. So this is all I want you to agree with me. Because you people said we always do B minus A, like the term minus the term before it. That's how you people come out with that too. Someone who said that we always use both, you're lying. Wrong cannot happen. Deep down in your mind, you also know you'd be like 10 minus 12. Then you get the negative 2 and be like, oh, so these people are multiplying, are subtracting 2. You get 4 minus 2, you get 2, you be like, oh, these people are adding 2. So the subtraction and addition come in later after for you, you've done some mental subtraction before in your mind. And that's what is most important. So you people have agreed. You have no option. So the other thing I want to end with is this. You have 2, 10, you have 50, 250. Here I just want 2 values. Forget me those 2 values. Even here. I also want those 2 values. But very fast. Very fast. And we are going to repeat the same game. You go to part D. This one, people have given me this. And these values are correct. Why? Because people have realized it is multiplied by 5 times 5 times 5. Then the last ones. Let's go to part D. Someone finally got it. That is 1680. Yeah, that is good. Why? We are dividing by 2. So I really want you people to borrow that idea. This idea we have been dealing with. You see this first of A and B. In A, we are subtracting 2. In B, we are adding 2. So I came here and made a statement and said that let's agree that as we check for the common term, that we are either adding or subtracting. This is the format we always follow. We always go for any term, then we subtract the term that is coming before, or what I call the preceding term. You understand? Then I came there. Same thing. I want you people to realize that for strictly this part C, for me to come out with that 5, trust me, I got my B over A. Even when it was multiplication, I had to first get my 10 over 2 to get the 5. Then I later decide, oh, that now the 5 is being multiplied throughout. You get the point? Even this last one, D, I don't want you people to pretend because you already realize it is divide by 2. I don't want you to say that for you got 5 1 to divide by 5 to 6. No, the order does not change. Even for this D, at least someone first gives it a try and they do this. Then they get a half. You get, after getting a half, everyone knows. Every mathematician is aware that 10 times a half is the same as 10 divided by 2. But you like it or not, it is still B over A. It is still B over A. Don't be fooled. It is still B over A, and it's what we are going to be using here. Where I ended with division, it may disturb you a bit, confuse you a bit, but you have to take it because it's all what the others are taking. B first, then A later. So in the first 2 cases, we are strictly dealing with subtraction and addition. But for C and D, I'm dealing with multiplication and division. But still, there is a very common order. And that's the order we are going to be following. So I will also come here and say that we are also going to agree that if a common term if we are checking is being divided or multiplied, this is what we do. I want you to all agree Because even if you just get these ones randomly, these ones here, you still have to say, you will have no option. Say this over this and get your half. Yes, half is clear enough to show you that we got the 64 multiplied it by half or divided by 2, whichever. Even when you're dealing with these ones, you'll have to come and pick this out and be like, oh, let me check, 250 over 50, then you get a 5. Then you be like, oh, the 50 was multiplied by 5 to come up with this. Period. So we are supposed to get any term. We are supposed to get any term and divide it by the term coming before, or what we call the preceding term. So this is where I wanted to take you all. That in the first case it was minus and subtraction. But to obtain that common term being added or subtracted, we have a general formula for it. And what is that general formula? It is here. It is a difference. This one. This is the very important thing I want. That minus. It is a common term which is being added or subtracted to get other terms, but the format we use to obtain it is actually a difference. So first things first, it is a common what? Term, hence the word common. And because it is obtained through subtraction, that is any term minus a preceding term, we call it a difference. Why I'm taking you through all this, when I was learning this topic, for me I used to get confused. And I'd be like, why do you call it a difference? Yet as we are getting the series, we are just adding 2 and 2. That's what used to beat my mind. That we are moving from 2 to 4 to 6 to 8 to 10 to 12 to 14. You know, I was a weak student. So such things used to give me a hard time. Because for me, when you talk of difference, I want us to just be maybe subtracting and subtracting throughout because of the word difference. But when I understood that when you're dealing with a series, you like it or not, to obtain that term they are commonly adding and subtracting, you just get any random term and subtract the one that is before it so that you get what is being added or subtracted. And that's why they used to call it common what? Common difference. And common difference is denoted with the letter D, or common difference. Then when I come here to this series, whether they are involving multiplication or division, for you to come out with what is being done to get other terms, get any funny term, you divide. One thing I want you to learn is that the term coming after is always the thing, then the preceding term comes later. If it is subtraction, the preceding term is subtracted later. If it is division, the preceding term is the denominator. Or I can say it is divided after. Okay, now, because it is something common that they are dealing with, it is a common term that they are either dividing or multiplying. So it is common. And because this time around we are having division, you all know, if I say 1 to 3, this one is the same as 1 over this. One thing I just want you to appreciate here is that this ratio sign can be replaced by the division sign. You get? And you all know that sign is what they call the ratio symbol. So here we call this one the common ratio. Common ratio. And common ratio is denoted with letter R. So when you see D, it is common difference, and you know why. When you see R, it is common ratio. So common difference doesn't matter whether you're adding or subtracting a series. Common ratio doesn't matter, doesn't mind whether you're multiplying or dividing in your series. Whichever you get after getting the any term divided by the preceding term, it is the common ratio. If it is adding or subtracting, what you get when you get any random term, subtract the preceding term, it is the common difference. Difference because of the minus, any term minus preceding. Ratio because of the division, any term divided by preceding. Therefore, whatever I've talked about in this first hour of the lesson, it is not examinable, but it will help you to understand, analyze scenarios. It's what's really disturbing us is that if at all the people who are responsible for the mathematics of the country decide to concentrate on purely scenario-based items, the math is going to be very hard. Remember, the math was hard before scenarios came in. Scenarios are word problems. Now, what if they make things word problems? That means you must have appreciated the English in mathematics before how things are just done. You see, if we just come here and we say A.P, first number, we do, you will understand. But have you appreciated what the topic is really all about? Do you have some history about the topic? Something that will make you have a beginning in case the topic is forgotten. It is so bad to recall this math using examples. Just recall it with some stories and have a beginning. Those of you who are going to do engineering, you need this. The people who don't need this are teachers. Whether you're going for medicine, engineering, you need whatever we say here. So you gotta be patient. So therefore, the series divided into two, the series with a common difference, the series with a common difference D, and then the series with a common ratio R. Now this series which always have a common difference D, they are the ones that we call the A.Ps. So the other name, the series are also called progressions. So that word progressions is another name. Another name for series. So the ones with a common difference are the ones they call arithmetic progressions. Then these ones with a common ratio are the ones they call geometric. So I don't want to begin these things when you know nothing about them. Geometric progressions are abbreviated as GP. Yeah. There are things you're not supposed to forget. That as you're writing any of those, because they are progressions or series, you're supposed to use what? Plus. So an example of what is having a common difference, 2 plus 4 plus 6 plus this plus the 3 dots. An example of what's having a GP common ratio, 2, 10. I think I'm using commas. That is very wrong. You know, you're supposed to use plus. So say 2 plus 10 plus 50 plus 250 plus the 3, like that. Common ratio, you know how. Common difference, you know how. So I may not exceed that as far as introduction is concerned. I now want to begin let me share our notes, you have a look. So let's read the notes together to save time. These are our notes for series. When you get time to read through this, you'll understand. Series, we just say they follow a definite order. For us, we just said order. But then they are saying for a series, it is a law. So look at the law as common difference, as common ratio. This sequence, just any orders, you people are just stating them. Then I remember telling you we have the first term, preceding term. So each of the numbers is called a term. You get? Like here, they are saying the first term is a 3. And I said that. These things will come later. Will come later when I begin maybe a P. Yeah. Now, here they're asking you, here they are questioning sequences, something which is easy. I just want to say something which I really never wanted to talk of here. There is something we are going to come across in this topic. Something they call the nth term, but I'll talk about it later. Nth term is usually denoted as U, which is capital, and N, which is a subscript. But I have said I don't want it to give you a time. Right now, we shall make it clear with time. But just take that, just digest that. When they say nth term, capital U, and then this small n. Hope you don't forget that. So this U, assume it's like term, and then this n as the subscript is there to bring out the nth thing. So this calculation you're seeing here is weird, and I don't want it to give you a time. It is obvious. They want you to form for them the first 3 terms. When you're using this key expression and they are telling you n is greater than or equal to 1. I told you this in probability. When they say n greater than or equal to 1, they mean n equal to 1 first, then n equal to 2. Because they have said the first 3, we shall not go beyond n equal to 3. Because they said the first 3. You get? Now, since the formula we are substituting in is n squared plus 6n, as you're getting the first term, but I'll teach you this. I just want us to follow the book critically. So as they are telling you to get the first term, you put 1 here, you also put 1 there, and put 1 here. The answer you get 7 is the first term. You understand? When they tell you to get the second term, you realize for second term n is what? Is 2. So you come here and put 2, you come here and put 2, you also come here and put what? 2 instead. What you come out with 16 is called the what? The second term. The last term which they want, because they wanted only the first 3. So the third term, n equal to 3, where there has been 2, you put there 3, even here you put 3. Of course, you don't need to forget that squared, yeah? then also here, put there 3. The 27 you get is what they call what? The third term. Now this is what I was talking of, that you're just simply following a certain formula. That's why they just call this a sequence. They may even tell you, try to find if there is any common difference or no, and you may not even understand. So I want to show you the difference. When you look at the space here, it is 9. They added 9. 7 plus 9, they got 16. But here they added 11. You get? These are what they call sequences. Sequences are very weird. You can find a sequence which is 1, 2, then 4, then 7, then 11, then 16, and then they do that. Then you realize this was plus 1, this was plus 2, this one was plus 3, this was plus 4, this was plus 5. Then you understand this is plus 6 plus 7. You get? They are not even adding something common. So this one ceases to be a series, and we just call it a what? A sequence. So I believe with all the bogus we have been speaking since the beginning, can help you understand that this is just simply a sequence and not a series. You get? So I think how that calculation was attempted is okay. They will not even set that. I assure you, they will not. But getting it is very fine. So I think you people get the replacement, that when we say this is how the nth term is written, nth, that's why we have n there. So when I say 10th term, I'll put 10 here. When I say 99th term, it is like that. That's just English. These things will not be hard. Now this is now more English. They are saying a series may end after a finite number of times. You get? Finite, fixed. They can tell you that a certain series has only and only 10 terms. That means it cannot go beyond 10 terms. That's why they call a finite series. That's just a good to know. No one is going to ask you that, but you need to know it. Then anything that is not considered to end, you all know in mathematics, that is infinity. That's why even here they are calling it infinite series, because we assume it will never end. Then they are saying that the types are two basically. That is the A.P and G.P. You get? And this is how things are taught in most books. They just tell you the types are those ones. But me, since they used to give me a time, I really always wanted to know what takes us to these types. Why are they telling us arithmetic and geometric before I cram? So we are going to begin this arithmetic progression, which is not very hard. Yeah. And trust me, most of the things have been said. You see, the stories are very little. Stories end around there, and then the calculations begin. But I don't do a lot of examples, you all know. I'll do a little, but I'm going to introduce everything. Then we shall go for GP. I also talk about GP. I do a few examples. You take a lot of screenshots for the assignments. You do the numbers in your free time, like that. And thank you for not making me shout today. I warned you already that I'm very sick, but I'm getting better. So I don't want you to bother me in the next remaining time. You have that tendency. So you keep up the audience. Okay. Now, basically in arithmetic, I'm not going to go into the English part about what arithmetic means and so on. That is now your own research. It's none of my business. But all you need to know with arithmetic, that we always have that common what? Difference. And that's all you need. That's all you need. But there is something weird that you need to learn, which I'm going to teach you now. You people are aware that with arithmetic progression, we come on right here. Arithmetic progression is common difference. But will people manage this? This is arithmetic. This is arithmetic. Okay, let's just name it as series. Lesson 1. Let me save. Okay. Enough of the stories. Now math. Arithmetic progression. So here we have agreed a common difference, which common difference is denoted with letter D. Now, I want us to use the terms we've been using. So progression, I don't expect any of us to use commas anymore. So I'll use this. So this is our series that we are going to use 1 plus 3 plus 5 plus 7 plus 9. Then that's what we are going to use to derive whatever I want us to derive. So I remember telling people that this is going to be the first term, isn't it? Then this one, I can now use things of second term. This one is going to be the third term. Something I want us to derive together. So stay calm and make sure you get the scenario. Then this is our fifth term. So when I look at this, we agreed that we are just adding 2, adding 2, adding 2, adding 2. And we all agreed that our common difference this time round, it is a 2. Because 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. So and throughout it is common like that. So it is our common difference too. That one we agree. I want you to learn, get this from me, that this first term, it is denoted Okay, let me just put it here, letter A. Then maybe I can fix it here so that you understand it. Denoted with letter A. You understand? Yeah, that is the first term. Denoted with letter A. Hope that is no news. But the other thing I don't want you to forget, that after us saying that nth term is this, why I left this space, I also wanted you to get used to these terms. So when instead of writing first term, when I come up and write my u with the 1, I don't want you to be bothered, because I know you know un is nth term. So when I say first term, I mean u1. Then for second term, it is the capital U, then the 3, then third term, like that. Because trust me, you're not going to be writing words each and every time, even if it's the 100th term. You just write U, then 100. Yeah. So hope you get that. But then I don't want me to be confusing when I now change my mind and say first term is also denoted with letter A, like letter A small a, denoted with letter A, which is small, lowercase. Just make those things your friends. Now, I don't know if people can realize that for us to get the second term, we got the A and added the common difference, isn't it? Because our common difference is a 2, isn't it? Our first term is 1. For us to get the second term, which is a 3, we got our first term A and added our common difference D, which is a 2, to come up with a 3. Then I don't know if people are aware that for us to get the third term, we got our second term, which is this, you get, and then we again added common difference, and hence we came up with A plus 2D, isn't it? Then when I come to fourth term, I don't know if you can still see that for us to get the fourth term, which was 7, we got our third term 5. But how does it look like? It looks like this, A plus 2D. That is our fifth term. We got it and still added more common difference. And then we came up with this 3D, isn't it? Just using letters. Then when I go to the fifth term, this is the most important thing in the topic. If you don't get this, you'll never get the topic. So when I come to the fifth term, which is 9, I got my fourth term 7, and I still added common difference. But my fourth term 7 is A plus 3D. Then I again added my common difference 2 to come up with a 9. And this is where I ended up getting this A plus 4D. And you people, that's all you need. That's the thing you need to understand, nothing else. And when you get this, the topic is done. But if you don't, nothing. And this is what you're going to use in all the examples we are going to be doing. But failure to get this, you're gone. Failure to get this, you're gone. What do I want to know whether people have gotten? I want to know whether people have gotten that first term is A, second term is A plus D, third term is A plus 2D, fourth term is A plus 3D, fifth term is A plus 4D. Is that okay? Remember, we also have GP, and we are also doing it today. I told you. We are doing it today. So we are also at one point going to write a certain series with a common ratio, and then we find out what is the expression of the second term, what is the expression of the third term, fourth term, fifth term, like that. So I really want to know, are we okay with how each of the terms is written in terms of A and B? Because that is the basis of the topic. You people, I'm waiting for you to comment. You're too many people, over 50. That's a very big number. You people, at least I expect 10 people to say something, because you're too many on the call, and we agreed you're not going to disturb me. So only 5 people have said the thing, then others. Okay. So let me see if people have a very good eyesight. And how am I going to test the eyesight? I'm going to come here and say that first term was A without adding anything. Without adding anything. So this 0D shouldn't confuse. It's like it was the first term with no common difference added. Then when we went to the second term, which is usually U2, we had A plus D. Then that term, usually U3. That was the fourth term. Fifth term, this is like a summary. So may I know you people are aware that D is the same as 1D. Yeah, it's the same as 1D. Now this is what I want people to recall. I want people to be quoting these things. We have here first term, that's why we have here 1. Second term, that's why we have here 2. Third term, that's why I have here 3. Fourth term, that's why we have here 4. And fifth term, that's why we have here U5. I don't know if people can literally relate these figures on this left-hand side. I don't know if you can relate those things to these ones on the right-hand side. How? I want to know if people see the relationship between those things I've circled in purple and these ones I've circled in blue. Been circling numbers. I don't know if you people are very good mathematicians. I don't know if people can see the relationship between those boxes on either sides. I don't know if people can get the technique. To test if really people are getting the technique, I want someone who is going to tell us how to write the sixth term without us continuing with our series, which sixth term is U6. Then I want someone still who's going to tell us the 11th term, which is U11, and someone who's going to tell us their 100th term, which is U100, using the same technique. Who can see the technique that has been happening between those figures on the left and these ones on the right? Remember, this A is constant. If you people can see the A plus, it is throughout A plus, A plus, A plus, A plus. Even the D throughout D, 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 and D. But now, right, what usually differs is that K number before D, which in one way or the other may relate to these numbers here, the subscripts which correspond to which term. You people write those three in the chat before I give a chance to Tugume, because I'm not only teaching Tugume. I want to see those three in the chat. You can see A plus is constant, even the D is constant, but there is a way those numbers that are attached to D are changing in response to the other subscripts corresponding to which term you're dealing with. Yeah, that is good. All of you have passed. You people, you see that thing you've been writing in the chat? That's all you need. Even if I end the topic here, you will understand whatever you learn at school. Trust me. Even if I just end the topic here, you'll understand whatever you taught at school. Because now you all have appreciated um that A is a constant, A is a constant, A is a constant. The problem is with this. We have all accepted that the D's throughout. Then you have also realized that if this is 6, should be one less. This is 11, this will be one less. If this is 100, this will be one less. But the other thing I want you people to recall, that this is n, isn't it? That is n. So I want, out of all these things we've been doing, right from the beginning here, what am I drawing? Okay, from all that, from all the above terms, from all the above terms, if you really need a nth term, which is like this, we have agreed A is a constant, but the disturbing part is that car box, then the D should come. So all of you tell me what I should put in the car box. Because we all know A plus is a constant, even this D is a constant, but the problem is what to put here, which should always relate with what is here. So this time around we have N. What should I put there? As also people prepare to tell me the rth term, where we shall put their R. Then as people prepare to tell me the K, and to see if you people can think very well. I just want to know what to put in those boxes, because I know all of them should have A. So far I have N minus 1, which is right, but I need all those. I need all those in order. So since what is supposed to be in those boxes is supposed to be one less, so yeah, we'll have N minus 1. Then the next box, I've said R minus 1 because it's supposed to be one less. One is also okay. What of the next term? The one minus, the K minus 1, that term. Someone is saying K minus 2, which is very okay. K minus 2, because it's supposed to be, you people, these things are supposed to be in brackets. Please don't forget the brackets. Though we have a box. Yeah, don't forget the brackets, because we're not supposed to use a box. Then this one, someone has said N, and they are right, because we already have we already have n plus 1. So when you subtract 1 to be mere n, and these are things they usually set and you get confused. But you just have these techniques, eh? No number will give you a time. Then the last one, p minus 2. People tell me p minus 2, p minus 3, because we expect it to be 1 less. So this one will be p minus 3. Of course, not forgetting the brackets. Yeah. With that, you will never find hard time, especially with this one of nth term. Yeah. That one is the king of the topic. So I'll put there, it is the king, the topic, nth term. These others are just to check your understanding, and they also come at the right time, and they also help you to interpret very weird scenarios. Okay. Now, you people know common difference, you know first term, second term, you know how to deal with random terms. Now I'm going to talk about the sum. The sum is the most important thing, nothing else. The sum. The sum, of course, of an AP. There is something I want us to learn today from first principles. That is 1 plus 3 plus 5 plus 7 plus 9. By the way, there are those of you who recommended your friends to join us. My book for principal math is getting done by Sunday. It will be ready. So all those who referred 5 friends, we agreed 5 friends, that was the deal. If you recommended 5 friends and they joined our lessons, you inbox me. I'm going to send you a copy for free. Principal math, all the 27 topics are there. The topics are 27. I don't know if people are aware. You look at this, and the last topic is flowcharts, yeah? And even have project work there. So the book is ready, and even the guidance to project work is there. And that's one of the reasons as to why I'm sick, having sleepless nights after the lesson. Even today, I'm going to stay awake to handle project work. So it will handle the chemistry book. Where project work is, I will also be putting their notes. So all those who referred their 5 friends, inbox me. I register your name. You give me your location. Those things will reach to you through certain delivery guys. The math book is ready. Those who haven't referred their friends, you have time. The holiday is still on. You refer 5 friends. When you confirm they have joined premium, you get your free copy. You also encourage them to invite others. Like that. I really want some people to get the books as free copies, so that you bless the books. Now, that is the series. I want us to analyze the sum together from first principles and never to forget it. Okay. You now know. I want us to first add those terms. Okay. First note. Have it in mind that some of the first n terms have it in mind that the sum of the first n terms of an AP is denoted as Sn, like that. I don't know if you people are aware. So if I'm not going to over explain about this statement, but let me test people's understanding by putting a question just below the statement I've not explained. How do you read S8? You write for me in the chat. Tell me how they read S8. Tell me how they read S1. Tell me how they read S of negative 4. Using that statement in black. You tell me, how do they read S8? How do they read S1? How do they read S of negative 4? That is the big question. For me, I've just put a note. I want people's responses. How do you read S8? I'll write it there. How do I read S1? How do I read S of negative 4? Before we go to the real thing. Sum of the first eighth term. That is wrong. Sum of first 8 terms. That is correct. Sum of the eighth term. Wrong. I've said Sn means sum of the first any terms. It is just any terms. So when I say S8, this K8 you're seeing here is representing the terms. Yeah. Even say total sum. Total sum of the first 8 terms here. That is it. That is the keyword, first 8 terms. Get the point? Someone read for us S1. Someone read for us S1. Sum of the first term. Okay, I'm reading your comments. Someone read for us S1. You read for me S1 and S negative 4 at once. Remember, this topic is full of word problems, so you need to understand. How do we read S1 and S negative 4? People are not easy. Yes, Zacharias, what do you want to say? People, that negative, terms cannot be in negative. That one has no name. Some of the negative 4 terms. Some of the last 4 terms. This one has no name. Baganda. Baganda now being creative. Some of the negative 4 terms. Some of the last 4 terms. That one has no name because terms cannot be in negative. Then the other thing I want to ask you people, this is S1, which someone can call like sum of the first term. You get? But are you aware that this is the same as the very first term? Who agrees with me that sum of the first, so what you may call sum of the first term is actually the same as the first term because the term is 1. No need of you saying sum, no need. It is S1, but trust me, it is the A. What someone can call you 1. Yeah, because you're dealing with only one term. Which one term is the first term? So there is nothing like sum. So that was a trick. So don't cram these things. There are those computation tasks they always give you, and they give you S1 is equal to 20. And according to your solution, you need first term as A. Then you start complaining. The question has a mistake. The question has no first term. Yet they gave you S1. So you be competent student to extents that can make you fathom that S1 is really the first term. Okay, that is good. Now, after people appreciating that when you see Sn, S is for what? For sum. N is for first n terms. Yeah. Sum, this one is first n terms. Okay. This is the series we had. Plus 5 plus 9 dash dash. Now these are the first two terms. So I'll put here S2. You're going to add them for us and you tell me the sum. Those ones are the first three, so I'll say S3. So you're going to add them and tell me the sum of those first three. And I'll proceed. First four. And I'll add them and you tell me those ones. First five. You tell me. So let me hope those S's don't confuse you. So you are now all aware that this thing, that one, is the S1, it is the U1, it is the A. Give me those values. There is something I want you to learn. 11, 13, 15. What do you mean? What do you mean? Yeah, that is it. Eh? So I don't know if people are realizing something. I don't know if people are realizing something. And I want to put it here. Like, what do I get when I do this? 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 Because we shall also need this. Eh? Do you people realize that when you get the sum, I want us to first interpret it in English. This one means the sum of the first two terms, and this one means the first term. You people, if I get the first two terms and I get their sum, then I remove the first term. Do you realize that I'll be getting the second term? According to English, without you looking at, don't substitute anything. Let's interpret it in English. When you get the sum of the first two terms, and then you remove the first term, do you see that you're remaining with only the second term? That is obvious. Now, what if you come and get the sum of the first three terms, then remove the sum of the first two? Like your terms, the first three are x, y, and what? And z. You have the sum of all these, then you come and remove, the sum of the first two. Do you see that you remain with the third? You know if people are getting it. So here you get the third term, which is U3. Hmm? Here they are talking of sum of the first four terms. Like you're having your four terms like A, B, C, and D. You get? You have the sum of all the four. You get the point? And then you come and remove sum of the first three. Do you see that you're going to remain with the fourth term? So I come and write fourth term. You get? Then we go to another one. Now this one is just obvious. You are having five terms. You have their sum. Then you remove the sum of the first four. That means you're leaving out the fifth term. You can get it in English. You can get it when you illustrate. You can get it mathematically, as I wanted it before. So also get these formulas. Also get those formulas. Now, before I hide them, I want people to tell me whether they have tried to make some little sense. People, do those formulas make some sense? You people, you see series are very easy. The problem with series is you not getting simple things. But when you have all these formulae, you're going to just reach there and just substitute. Just substitute, just substitute, just substitute. You just substitute. You people, do they make sense? Please tell me if they do. I want to ask something. Let me see. You people, you're more than 40. So you should say something. Do those things make sense? We agreed that you're not going to give me hard time, but some people have already started. Let me see those people who have logbooks. If you have a logbook, you say I have. If you have a logbook, you tell me in the chat that I have. There is something I want you to help us with. Okay, Pauline has. Anyone else who has a logbook? Because we may need it next. Even Capta, even Joel. So you're going to go to those formulae. Yes, you're going to go to those formulae even Alan has. Let me try to also open mine here. I think I should also show you mine on the screen. I have my logbook, but I want people to buy your own. So don't ask me to send. Yeah. Okay. Now, you open formula. It may not be the exact formula, but you go to mathematical formulae where the formulae begin from. Around there, formula 7. Are you seeing formula 7? Is it there anyway? On that very page where we have mathematical formulae, do you see series there? Do you see series there? That formula, okay. So what is the first formula of series? Is it formula 6 or formula 7? That page. Okay, let me show people the logbook. But you tell me, which is it? Because according to my old logbook here, it is formula 6 first. I don't know what of you people that side. Let me hope you can see my logbook. Oh, it is formula 6. Hey, that is nice. That means we have the same logbook. So according to the logbook, you tell me the page. What is the page so that people can have the right reference? Is it page 59? Okay. Page 59, somewhere we have series and we have this formulae. So I think you can see where we are. We are somewhere here. Are you seeing? Sn, which means sum of the first n terms. So this formula is in the logbook. The mere fact that it is in the logbook, you don't even need to know how it is derived. But I will give you that as research work for those who really want to go an extra mile to find out how the formula comes about. But usually they just want you to use it. And following the fact that is in the logbook, I don't want you to stress yourselves, people. Yeah, don't. Just learn it by heart. Just because you people never did the old curriculum, but it had a lot of formulas in O level. But still, you are this, like you are also students. So we were also students. So if we could understand, that means you people would also do the same. So I don't want you to say you're very young, you cannot get these so many formulas. You can. The brain has all that space. So the formula is, we are going to learn it together. So for an AP, because even for a GP we read it the same way. So for me, I've decided to teach you all concepts about the AP before I even start calculating something which is dangerous, but it is yielding. So you're going to get this together, the sum of the first n terms, like that. The formula is, you write n, you get over 2 over 2. Then you use these brackets, the square ones. Then you come and write 2a plus, here you write n minus 1 d. Anyway, let me teach people something at least. I don't want you to be pissed. Let me not write what is in the logbook just like that. Let me benefit my doctors. So you write n over 2, then that you say, I get my first term, plus the last term. Like that. A very good formula. You all know this one is denoted as A. Then this one has two things. The first thing, it is denoted as, it also has a denotation. It is denoted as L, small l, just like that, small l. Then the other one, it is nicknamed as. So in this topic, the last term, that one that usually comes last, they always call it the nth term. So you learn that, eh? So that last term that comes each and every after any series, they always give it n. That's why I can even come here and say, here we have un to mean nth term. So you get that? Yeah, the last term, it is usually nicknamed as the nth term in mathematics, specifically under this topic. And you all know that the nth term, there is a constant, something must be here, then d. Get the point? Then here we have n minus 1. Hope you all know that here it is n minus 1. So you either use this, someone may say, some of the first n terms, I always say n over 2 into a first term plus l, you get, and they stop there. This one is accepted formula. Accepted formula, and you can use it. Yes, you can come across a question and it is the one working. Or someone can substitute for the last term and they say that this one, the last term is the nth term, which is like this. You get a. A plus the last term, which is also a plus like that. This a is alone, and for it was for the first what? First term, like that. This is also different for the last term. So when we try to correct like terms, a plus a gives us 2a. And that's how the formula in the logbook comes about, but it has a derivation. Yeah? So because we are having curved brackets coming again, we can transfer these ones to square brackets. Or you can decide to use curved brackets, whichever you want. So it is this. That is the formula, showing the sum of the first n terms. What I may add on here, but your research work shall be the detailed derivation. You people, we are on page 7 and I've not done any number detailed derivation. We are just saying stories, and we have come to the end of the stories. Now, you are not going to meet any calculation that requires you to use any concept I've not talked about. So my role is done as a tutor. The rest of the work is supposed to be done by discussion groups. Yes. Yep. So, comments about the sum. Are you seeing all that information about the sum? Hey. Yet it is something I just had to state and tell you what things mean, period. But I had to narrate because I enjoy the stories. No one has been telling me about screenshots today. So hope when we lose the document, no one is going to complain. No one has been asking for it. I don't know if people are making use of the paste to also write down notes. I don't know. So this one is the first term. This one is the common difference. And you all know this one means the first n terms. So the n is like the number of terms, period. If they say n 9 terms, n is 9. So that one is like number of what? It's like number of terms. Yeah, number of terms. So I really don't think there is any formula whatsoever that we are going to come across and it has not been done. You people even have who have the p minus 2th term, the k minus 1th term. You have all the denotions, you have the origin, you have agreements, you have the terms preceding, succeeding, proceeding. You have where the sequence yeah, you will enjoy. You will thank me when you reach campus. Okay, let's go back to our notes. Are you seeing now this book out of the blue? It used the word preceding, but you read through, you will understand. Oh, these ones are obvious. Common difference is not in use. The word preceding. Are you seeing? You read that statement I've circled in purple. Assume you read it before our introduction. The difference between each term and the preceding one is called common difference. You would cram, trust me. Yes, trust me, trust me, trust me. So I want to give you this note before we go any further. I want to give you this note. Are you seeing this one? It is an A.P, isn't it? I also want to look at this one too. Let me use cost subtraction. Maybe I begin from 30 to 25 to 20 to 15 to 10, like that. Now here I'm going to randomly choose these ones. Then here I'm going to randomly choose these first three. Then when I come, I'm going to choose 3 and 7, and I'm going to say 3 plus 7 over 2. Then I get 5, which 5 was here in the middle. Hey, then I'm going to come here, I'm going to choose this 30. Then I say 30 plus that 20, I get 50, over 2, I get 25, which 25 is here. I don't know if people are seeing something. Hey. You people tell me, what can you say? The best comment is going to get free classes. What is the best conclusion you can make from that? You can even choose this. You may say, why are you choosing those? You choose those ones. And pick this 20 and this 10. Divide by 2. You get 15. Which 15 is here. What do you realize? What do you realize? Anyone good at English to make a statement out of that? For any three consecutive successive terms of an A.P. For any three consecutive stroke successive terms of an A.P. These ones, A plus B plus C plus that. I want someone to tell me, what should I expect when I get my A and C and I divide by 2? What am I going to get? You failed to make the statement on your own. Now you help me complete it. At least you help me complete it. You people, A plus C over 2. What am I going to get? People, don't annoy me. Okay, all of you have passed. It is B. So we are dealing with arithmetic progression. Yeah? So that B is what they call arithmetic mean. Hadley has made a very good comment, meaning she has been following. Yeah? Thanks for that, Hadley. That's what they call the arithmetic mean, that for any three terms, when you get the first and third over 2, you get the second. Yeah? And that what you get as the second, it now becomes the arithmetic what mean. So I don't want you to be doing a scenario set by a very good mathematician. They tell you that the series is having only 3 terms. They give you the arithmetic mean, and according to your calculation you need the second. Then you start complaining that they gave us arithmetic mean, but they never gave us the second. Yet they told you it's finite with only 3 terms with that arithmetic mean, and you really want the second? That's quite absurd. That's just a technique. So as you're reading through these notes, I also endeavor to put them on the drive, though no one reminds me to. So maybe people have better formats. You can see L denotes the what? The last term. Here they are using capital L, but in mathematics they care less. Whether small or capital, but it is usually small letter in textbooks. Because that's why first term is small a and not capital A. Common difference is small d and not capital D. So they prefer even the last term to be a small letter and not a capital letter. But when you do it in an exam, don't develop a lot of pressure that you failed. You've not. So here they gave you the two formulas without showing you the relationship between the two. But I believe you know the relationship between the two. So this proof part is what I'm not going to teach, and it's what you're taking home as research. But I think I should not do for you an example. Can't you people learn the hard way? So this is the proof for your research. A bright one has taken the screenshot and they will follow up later. So finally, examples are beginning, but I don't know. Okay, let's do them. Let's do them anyway. Now, you people, you look at this question. You look at this question. They are saying they want the sum of the first 100 numbers. You get? Yeah, that was the question. They want the sum of the first 100 numbers. So when you decide to do that, sum of first 100 numbers. Of course, when they say first 100, what is going to come to your mind first is wanting to list them, yeah? 1, 2, 3, blah, 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 up to what? Up to 100. But the problem with this, you're using commas. Which commas are haram in the topic? What is halal? The plus sign. This is the old fashion for sequences, so it is out. This is what is supposed to be done. 1 plus 2 plus 3 plus plus 100. You get? Now, you people, you don't need to suffer with this. Really? You are having the first term. You are having the last term. They have told you the first 100 numbers. That means, who can tell me what is the value of n? If they tell you the first 100 numbers, what is your n? Is your n 100? Is it 101? Or it's 99? If they tell you the sum of the first 100 numbers, remember the formula is like this, eh? Sn n over 2, you get? This is a over l. You people, this is first term, which you have here. This is last term, which you have here. Why would you really go for the other formula? If I put it here, it is like this, n over 2. I said you can use curly brackets, 2a into n minus 1d. Then you close with curly brackets. Which formula is really better? The last term is here, 100. The first one is here, it is a 1. So my question is about this n. The question said first 100 terms. This one is read as first n terms. So what is the value of n here? Is it 99? Is it 100? Is it 101? Only 2 people have said. Then others, you said you're not going to annoy me, but you have already started. This other formula, you have a, you have the d, common difference. You can get it, yeah? You get any random term minus the preceding term and get the common difference, provided it is any term minus preceding. Even when you're dealing with dividing, provided it is any term divided by preceding, you're on the right track. What is the value of n? Okay, 100, because this is Sn, which is sum of the first n terms. You get the point? So when I say first 100, so n is 100. So I'll come and put there 100. Today we are going to do some numbers before we sleep, and we are going to do them from the WhatsApp group. Yeah, but I'm going to leave them here. But don't worry, they have answers. So I want, before anyone sleeps, when those numbers have been posted with the answers expected. You understand, yeah? Yeah. Posted with the uh, answers expected. Now, those who will be listening to the recording, you may miss this, but the good thing, the questions are going to be having answers, so you can literally also follow up wherever you will be. So do you see that number? I'm going to just use this and substitute. So as I'm responding, I'll come and say they need the sum of the first 100 terms. So my n, it is even very clear, 100 has replaced n. My first term is a 1. My last term is 100. Then you put the answer. You people, these series are not hard. As a student, this topic gave me hard time because I used to cram formulas. So when I get to a question, even when it's very easy, I don't have options. I crammed my each formula. I put things I don't really need and all that comedy. So you have the best introduction, even when its pace has been down. But at least you've been following. It is my first time to reach such a number at 11 p.m. Hope the 70% is not dozing. So what is the answer there? We have those friends who are always there for us. They tell us what the calculator has given even when they are not understanding anything. So please, what do we have from the calculator? Repeat. We are supposed to have a meeting after here. So I'm supposed to conclude series very fast. We now have the principles. I'm going to just enjoy. I don't know which formula these people used, but we have the answer. You look at this number. Do people get this statement? I remember telling you people, you tell me what I'm supposed to put here. I need you to tell me what to put there. You people, when I get the sum of the first 5 terms and I remove the sum of the first 4 terms, which term do I get here? Fifth term, fourth term. Which term do I get there? Fifth term, fourth term. Fifth term, fourth term. Fifth term, fourth term. I want to see 5 answers at least. And how those are 4? Fifth, yeah, that's it. Fifth term, and how is it written? Written like this, U5, U4, U3. So do you people see this, that if this is n, this is n, but this will be n minus 1. If this is r, this is r, this is r minus 1. If this is k, this is k, and this is k minus 1. You've not crammed, but when you come across something like this, it will not give you hard time. So I'm not going to go through this number. It is yours. It's not even research. It is just a task. Because you know what it really means. Here they just substituted. They just substituted in this. Trust me, you'll understand. Provided this is okay. This is the only thing that may give people a time wondering why is it like that. But for me, I gave you this. We even had some inline tasks in line with unknowns. That is not a problem. You look at this number. They usually set such, but they are not hard. They are saying 3 numbers in an arithmetic progression are such that their sum and their product. Then they want you to find those numbers. They give you 3 numbers. They tell you they are in an A.P. Then they give you their sum and they give you their product. But this is algebra. It's not even series. That's why I didn't want to teach this thing. It's not even series, but algebra. Let me show you the technique. I want you to look at this was a series. If you recall, I'm going to pick out these and also these ones. So these ones are 1, 3, and 5. Then these ones are 3, 5, and what? And 7. Then also, I'm going to have others here. Those ones that involve subtraction, yeah? So 20 minus 5, 15 minus 5, 10. etc. Then I come, I get this. Then I also come and get this. So I want you people to look at this, this number in the middle. What if we say it is our A? Just assuming. And also we say this one is our A. Do you all realize, remember the common difference? Here the common difference is what? Is 2. When I get any term minus the preceding term, yeah, I get 2. 5 minus 7, 2. 5 minus 3, 2. 3 minus 1, 2. Then here, who can tell me the common difference here? In this second series, who can tell me the common difference there? If you follow our criteria, what is the common difference? If you follow our criteria of any term minus preceding term, what is the common difference there? What is the common difference there? -5, yeah? Because 10 minus 15, 15 minus 20, 20 minus 25, all of them give us -5. So I want people to realize, or I want people to appreciate that this one, according to common difference, it is that a the 3 minus the common difference. Isn't it? We have just assumed that this 3 of ours is our A. So the 1 is 3 minus 2, which is A minus D. Then this 5, just assuming A plus D. Isn't it? Even when you do it here. This one shall be 5 minus 2, which is A minus D. Then this one will be 5 plus 2, which is A plus D. Then when you come to this one that was extracted out, it is 25 plus 20 plus 15. So when we get this one in the middle, and we say it is A, I want you to listen. Remember our common difference is what? To get 25, of course, we say 20 minus the negative 5, isn't it? Which is also a minus what? A minus d. Then to get 15, what do we say? We simply say 20 plus maybe negative 5, which will also be our 20. We agreed it is our a, plus we agreed the d is a negative 5. Why I'm doing all this? So the same thing is going to come out here. I don't need to show you again. One thing I want you to appreciate is that for any AP, any three consecutive terms, any three consecutive terms are a minus d, a plus d, very stupid, a, then a plus d. This is what I wanted to teach you. On top of all the other things of arithmetic mean. You see, this topic, as I've said, it has a lot of tricks, and it's those tricks you're supposed to learn only. I'm not supposed to do for you a lot of numbers. This mathematics is all about getting the concept, then do work in discussion groups. Even if you're at a school where you're the only math students, find friends online, find friends from other schools, meet up and discuss. You're not going to pass if you don't discuss. You may pass, but you may not excel. That's the fact. It's very easy to win as a team rather than an individual. Okay, and I'm happy today people have tried to maintain numbers and discipline. That is good of all of you. So, is that okay? You people, is that okay? Have you gotten that thing of a minus dA and a plus d for any three terms that are near each other in an AP? Do you get that? Only one person is saying okay. We agreed that you're not going to annoy me, but you have started. Only 3 people out of over 30 people. You take a screenshot and put it in the group. These people are going to help you. Everything you don't get, for you just take a screenshot. After the lesson, put in the discussion group. Ask people. They will respond, and I also come in to confirm. You get it? That's the role of the discussion group. So after you do the needful. Now when I come back to our PDF, do you see that that's what these people did? People, these things are very easy. You see, they said, let the numbers be, these are the numbers they let. So let me hope these numbers won't confuse you. Then they said using the sum, they said the sum was 27. So they added all of them and they found out that 3a was 27. So they got a as 9. Do you see? Things are not hard. They said the sum was 27. When you add this, do you see that this one cancels? I think this is negative d, this is plus d. So the d cancels and you remain with only 3a. That is after adding. So the sum is equal to 3a, then they get a as 9. You understand? A. Then they go to the product. So after the product, they have a and 9. They have a as 9. So do you see? They substituted wherever they had a, they put 9. You get the point? Hey, you people, this math. The rest of the things are algebra. Here we don't have any series. So you people have said, like that question those people were doing, they said the sum was 27. So we agreed you're supposed to first put these things in brackets, then after you open brackets. So you realize this one is obvious that negative d and positive d, they will cancel. Eh? These ones will come with that. So you remain with a, 2a, 3a equal to 27. A is 9. After getting 9, they told you the product. They are 3, so that is their product. Product means multiplication. Their product is 504, like that, isn't it? You come and substitute. A is 9. D is what you're looking for. A is 9. A is 9. Plus, remember we are looking for value of A and D. Now you first get rid of this 9. Over 9 over 9. Now there is a technique here. You people, all of you know what they call the difference of two squares. I think I talked about it in partial fractions. Are you all aware that that thing is the same as 9 squared minus d squared? Are you aware that that is the thing? So we get 56. But 9 squared is 81 minus d squared. Using mathematics, what do we get when we add those two? So this is 46. But am I getting the right thing? I think I'm tired. What do you get? But was the product 504? Yes. What do I get? Is it 56? Then here we get 25. Then you all know the square root. The square root is either a positive or a negative. Yes. If there is need for verification, you verify. But you people, to be realistic, is that hard? They told you any terms. You get? This was proof, yeah? Yeah, they were trying to prove. They told you that if you take d as 5, these are the terms. When you take d as negative 5, these are the terms. So the one marking, we choose the terms they want. But usually they give marks for both terms. You understand? The question wanted terms, and to get terms, you needed the value of A and the value of D. But the value of D had two values because of square root. So two series are expected. One thing I advise, because the question said it is a progression, avoid commas. Avoid those commas. So if when you're writing that, please use the what? The plus. But before you even go any further, do you really get that math? Do you see that we don't have any series there? The series only helped us to get the terms we are going to use in the algebra. But the rest of the thing has been solving equations, normally solving for unknowns. So those who have gotten it, just say next, next. Someone has said use scenarios. You people, I told you the problem that most of you are facing, you want to deal with scenarios first. That is very bad. I told you the mode of revision in math according to your curriculum. And let me tell you the secret. Right now, they are currently proposing Right now, they are currently proposing that you people, the papers should remain as they've been, so that section A is maintained when it is having computation tasks. Like those of old curriculum, you get. Then section B will have scenarios. But that's a proposal. It may or may not come true. So please, you're supposed to respect the questions of old curriculum. And after this proposal being heard by other science subjects, even the top people of this other subjects are proposing the same thing. That some questions of the old curriculum should stay because scenarios are not easy to come up with in certain topics. But then, what of a student? What should be the mode of revision? This is what I advise, and you should please go with this and nothing else, because there is no shortcut. Please get the concept. After getting the concept, revisit the concept, or what they call revising, to understand the concept. After that, you now do a lot of computation tasks. Computation tasks, those ones that don't have any real life problem in them. The ones I usually give you computation tasks. Then after the computation tasks, you can now go to the scenarios. Scenarios last. Because trust me, you cannot pass a scenario if you failed computation tasks. So this is one thing I ask. If these ones are okay, if the computation tasks are not okay, you either go back and re-get the concept from scratch, or you revisit the concept. But if they are okay, you can now proceed to the what? To the scenarios. That should be the mode of revision as a student. You should even take a screenshot of that and share to your friends. Get the concept, revisit it or revise to understand. Then do a lot of computation tasks. When you do a lot of them, you're now mastering. Yes, when you do a lot of them, you're mastering that concept. Then you can go and do scenarios. These scenarios are now making you what? Competent. But here's you're getting the concept. You're getting the concept from what? From scratch. Like right now. You people, you're not understanding. What you're doing right now is to simply appreciate that, oh, S subscript N is read as some of the first 10 terms. Okay, you've appreciated. But tomorrow morning, you can fail. You can fail to say the same thing. So you're supposed to revisit, revise to understand. Do a lot of computation tasks to master. Now handle scenarios to become competent. So for us, we are not competent. We just stopped at mastering content. But we are people who are setting scenarios. So that means we also have some bit of competence assumption. For us, we just assume we are competent. But have it in mind, the country has a lot of hope in you people, because your curriculum is convergent towards job creation. But the more but I don't know why, ever since the curriculum came in, unemployment is on a very high increment. So we are waiting for you all to leave Form 6, get into VAC, and create jobs. So have it in mind, the country has lots of hope in you, because you are the first cohort for the new curriculum. So hope I've answered you, Elijah. Only 3 people told me next. I want 10 people. More 7 people tell me next. We go to our notes. So we are moving. 10 people tell me next. I go to the next thing. If you don't, I will not. 10 more people tell me next. Okay, now you people, you see this car thing, eh? They are saying the first term is 25. You see this topic, eh? The examples don't even relate to series. Like, for example, this key example, they are saying the first term is 25. So A is 25. The third term is 19. You all know the third term. You leave some space. I put here D. They are saying it is 19. If it is third term, what should I put here? 2 or 4? It is third term. What am I supposed to put there? 2 or 4? It is third term. Do I put there 2 or 4? I put there 2. I put there 2. That is good. Then they are saying, find the number of terms in the progression if its sum is 82. They are saying Sn is what? Is 82. They're asking for the number of terms n, isn't it? You people, you have the value of A, isn't it? Do you all see that when you come and put here 25, we can get this value of D? All of you use your heads and tell me the value of D. Remember, first term A is 25. You put it here. It is equal to 19 third term. What is the value of D? Just use your heads. Tell me, use your heads. What is the value of D? What is the value of D? But use your heads. 19 minus 25 over 2. Negative 3. So you have even D as negative 3. You get? Like this one is 25. This way you have 19. 19 minus 25, negative 6 over 2, negative 3. You get? Now, what is Sn, the formula? The formula we had was this, n over 2. We have that one of first term plus last term. But since the question is not mentioning last term anywhere, it may give us a time. So we go for the second, which is 2a plus n, sorry, it is n minus 1 over 2. You see that? Now they are telling us that this one is 82. So let's equate it here. You get? This A is 25. This D is negative 3. You people, you want to tell me that none of you can get this value of n? What I want you people to see is that this topic of series has no content. What you have to understand are those things I've been deriving for you from scratch. These other things are substitutions and algebra. Like, look at that. We have 82. We have the value of A. You get? We have the value of D. And they want the value of n. Is there any of you can fail to get the value of n? I want now to see people's comments in the chat saying, I can. I want 20 comments telling me that you can get the value of n because that's what they want. And it is the number of terms. The number of terms n. I don't know if people are getting my explanation, but literally, Series. I literally see no problem with them. Only two people can get. What of others? Others, aren't you following the explanation? You're dozing. Only 3 people? More 2, okay. Okay, one more. Okay, that is good if you can. So I'll skip that. I'll not even waste my time. The working is even here. I see that we are handling series, but somewhere you're going to solve a quadratic equation. Which quadratic equation? I taught under numerical. You go to numerical concepts. These numerical concepts are in senior 5 term 1 work, of course, on the drive. You go to the math drive. Those of you have issues with quadratic equations. Math drive, senior 5, numerical concept. You watch the lesson. That lesson you're going to find there. You watch it. That work is there. You look at this question. They are saying the 13th term is 27. So for you, all you need to know that 13th term is like this. Because of 13 here, it will be 12 equal to 27. So the only trick is this 12, and that's where series stop. So this is equation 1. What else? They are saying the 7th term is 3 times the 2nd term. You listen, they are saying the 7th term, because of 7 here, we shall have 6. What are they saying? They are saying it is 3 times the 2nd term. The 2nd term, because of 2nd, we shall just have here 1d, which is like that. You get the point? Then when we simplify, this will be a plus 6d. This will be 3a plus 3d. Then we shall come out with 2a minus 3d equaling to 0, which when we simplify, it will be like this, where we can even get the value of a as 3 over 2d, which you can call this equation 2. I don't know if people realize that this is where a series stopped. 13th term, you put there 12. This one is A, this one is D. 7th term, you put here 6. What are they saying? It is 3 times the 2nd term. You put here 1. Then the rest is algebra. I want people who can solve equation 1 and 2 to tell me I can. Because these are things I taught in that very lesson. I remember we talked of how certain equations may be solved. And I really don't want to go back there. These are equations people have been solving since O-level. So who are those people who can solve equation 1 and 2? Please, if you cannot solve, this is your future. Don't follow peer pressure. You say, I cannot. Yes, let not peer pressure and bandwagon drive you. You say, I can't. None of those people in the chat pays for your fees. So one more person. Okay, 5 people can. I'm going to put some work that you're supposed to do after this lesson. Please, I want to see people recording voice notes and taking their friends through the work. Yes, if someone says repeat that step, repeat for them. You people, I want you to sit down and make notes from all the work on that drive. Trust me, 3rd term is a very short term. We may even cover what you will cover in senior 6. So I am always trying to look at those topics that may come next term. I will by force upload senior 6 videos, which may be taught next term, so that you go through them and also interact in that discussion group. You make notes so that by the time, even if you have 3 topics, even if you don't complete the drive, but you have 3 topics you're sure of, the pressure will not be too much. But some of you just attend 4, you don't make notes, so you don't see any change, trust me. Okay. So where are we? Example 8, they're saying the sum of the first 20 terms So for us, we know sum of the first 20 terms is this. Now find the sum of the first 20 terms, sorry. So we know n is 20. With the first term 3, a is 3, and common difference are half. Common difference is a half. This is the formula. Sn is n over 2, 2a plus n minus 1 over d. It is in the logbook, but I taught you how it simply comes about. The n we have it is 20. The a we have it is 3. N we have it is 20. D we have it is a half. You people, do you see that it was really worth it for us to waste a lot of time on how these formulas come about, to make them our best friends and so on? Because literally, what is this? Which math is really there? The formula is there. Every information has been what? Provided. That's why I wasted a lot of time, so that you people know that common difference is D and not Q. So that you people know that first term is A and not N. So that you people know that the first 20 terms means the N is 20 and not 19. This is why people, I waste a lot of time on introduction, because I want to secure my future as far as this is concerned. You see, in this education, you spend more life at school and alone than with even your teachers. So your teachers should always do their best, like I'm trying, because I'm also your teacher. So I'm talking on behalf of my colleagues, that we should always try to give you foundation. Then you struggle after having a very good foundation. But we shall not be there to spoon food you each and every time. Me coming here to do over 20 numbers with a very fake foundation doesn't make me feel like, yeah. But if I give a very strong foundation, even if I don't do any example, I know I've left the right people. So do you people see how easy that is? It's simple interpretation and substituting in the formula. Now, like, look at this one. You people really look at this number. They are saying find the sum of those series. They are giving you this 6 as the first term A. They are giving you this 50. It is very clear it is the last term L. You don't even need to use this formula these people are using. Are you seeing? Now even this person was not sure of the other shortcut. Remember we said you can say that the sum at this point, the n may give people hard time. This is a very good number, and I've liked it. Let me try to show you. It is 6, 10, 14 up to 50. Look here. But it is also not so hard, but a bit sensitive. It is 6, 10, 14 up to 50. So this 50 is the last term L. This 6 is the first term A. When you try to get the difference here, if you choose 14, the preceding term is 10. So you said my D is 14 minus 10. You show that step. Then you say this one is 4. So don't forget to show that step, yeah? You choose any term. We said any random term. So remember they want the sum, yeah? So assuming you panic, remember you have your A as 6, A is 6, D is 4, last term is 50. So when you panic and you really want to get the sum, maybe by this, you have A, you have L, but you don't have N. Even when you change to the other method, N over 2, which is having 2A, N minus 1D, it is also having this N, and this N won't allow you proceed. But then recall you have the last term, which last term is always nicknamed as the nth what? Term. And that term is a 50. And you all know this is its formula. I don't know if people recall nth term, yeah? We all know this is a constant, but we have d here. When we are looking for 6, we put here 5. 50th term, we put here 4. We always make it one less, yeah? So here we always have 1 minus d. So people, you look here. I just want to make this interpretation. Do you realize that this side we have 50? Here we are having a, which a is 6. Here we are having d, which d is 4. You get the point? Now, do you see? We have 50, we have 6, we have d. Do you realize that we can get n and later come back and use this formula? Because we shall have our L as 50, we shall have our A as 6, we shall have our n as obtained from this formula of nth term. Do you people need me to show the working, or the interpretation is okay? Have you people seen the trick? I first wrote the formula for sum of n, sum of the first n terms, or that formula for total sum. And I realized I have whatever I can substitute apart from n. Then when I looked at all the information that was provided, I could make use of the nth term. And when I wrote the formula of the nth term, I realized nth term is present, which is the last one, 50. A is present, which is 6, and D is present, which is 4. So I could use that expression for nth term to get the value of n. And after getting the value of n, I take it to the other formula of sum so that I get the sum the question wants. Do you get it? This thing is simply algebra. We are not even doing series. And that's the most common thing in topics of pure math. We usually get the concept and then the rest is maternal math. That's what I usually call it. So, are we together up to that point? I don't know why people are quiet. You raise up your hand, say the point. You text it in the chat, you say pardon, or you raise up your hand and ask. But I hate it when I ask and people just stay silent. Only Christina said we are, then others. One more person. Period. Okay. People are getting. Let me hope so. So example 10. I don't know if people can even believe that we have so far covered 10 examples. Hey. Okay, yeah, they are saying the first 4 terms of an AP are these ones. They are the first 4. Then they are saying find the 30th term and the sum of the first 30 terms. Are you listening? So from that, we can realize that our A is 5 because it is the first term. Then when I pick any 2 terms and I subtract the preceding term, I realize that my D may be, you see here, this person chose 11 minus 5. For me, I can choose the last 3 and I said 23 minus 17. Still, I get the same what? Value 6. So I have the value of A, I have the value of F5, I have the value of D6. You get the point? They want the 30th term. You look here. You all know anything term, but I don't even need to do anything. People, 30th term, you all know A is a constant. Something must be there, even D is a constant. Because of 30th, I put here 20 what? 29. I have the value of A, I have the value of D. A is 5, D is 6. You people, can't you get the 30th term? They are asking the sum of the first 30 terms. If a person never mastered how these things are denoted, those are the people who will be writing the whole word, sum of the first 30 terms. Yet you're supposed to just write S and 30 as the subscript. Then you all know, okay, you all know, okay, let me put here the formula. The formula is Sn. Here we have n over 2. Here we have 2a plus n minus 1d. All this covered inside. So n over 2, it is 30 over what? Over 2. 2a. A is what? 5. Plus n. Who can tell me n? What is the value of n? Because I'm supposed to say n minus 1, then d, which d is 6. So you people, it is not good to put the 6 here as the d. You should be organized mathematicians. Even when the d is after, for you can put it first, then you bring the n minus 1 here. People in the chat, what is the value of n? It is 30. 30 minus 1. Because they said sum of the first n terms. So n is 30, and that's why it is here. You people, for sure, for the time I've taught this topic, I've not seen series applied anywhere apart from the things we discussed. These examples have no tricks. They have nothing. They just need an open mind. Someone who can be like, what is the 30th term? Which is the formula of the first 30 terms? That's why I wasted a lot of time there. So that when you reach these things, you see, you're supposed to do a lot of numbers. A lot and a lot. Yeah? So I don't really think I need to go through all this. Just believe people are sorted there. Let's come here. What are they saying? A.Ps the first term 2, so for you come and say A is 2. Nth term 32. So instead of nth term, I come and do this. They are saying 32. So for me, I know that this A is 2. So I can even say my D into n minus 1 is 30, isn't it? In case this 2 goes the other side, this one becomes 30 because it has found there 32. You see? They're saying that given the sum of the first n terms, so they are saying sum of the first n terms is this. Sum of the first n terms is this. So what do I have here? N over 2. And people, these things are very easy. Remember, you know that it is A plus L. Isn't that the formula? And you people, I remember telling you that this L is nicknamed as nth term. Isn't it? This value of A is the first term and it has been given in the question as a 2. The nth term has been given in the question as 32. You people, even the formula the person used in the book is very hard. But you people, don't you see? You are having this. You are having this too. You are having this, that too. Can't you get this value of n? You people, do I really need to do that for you? You first tell me, can you get the value of n? You tell me in the chat. You just say, I can get the value of n. I don't want to do for you this algebra. I believe you're math students and you're okay with the algebra. Can you get the value of n? You just say in the chat, I can get the value of n. I want full statements. Say I can get the value of n. This series, you're going to look at numbers and you're going to get confused. But what you're supposed to do is to go back to our introduction and make sure you get things from scratch. Only 3 people can do that. What of others? Okay, that is good. Now, those who can get the value of n, I want you to look here. Look at that very big arrow, that big arrow. Do you see that big arrow? When I come and substitute for the value of n, I can get the value of d because I've used this to obtain n. Now, when I come to this arrow, that one, that arrow, do you see that when I substitute for the value of n, I can get the value of d? Do you see that? Now I want to say another statement. I can get the value of d. I can get the value of d. You just copy, edit, remove n, put d and send. I want 5 people. Say I can get the value of d. I can get the value of d. This math, you just practice. Someone may be like, why are you really concentrating on n and d? The question said find the n and the common difference, but we all know common difference is what? Is d. Do I have the 5 people can get the value of d? Yes. So people, these series are not hard, but you're supposed to practice these things. Now look at this one. Look at this one. They are saying the third term, which is this, they are saying it is this. You can see here, they mentioned that as equation 1. The 5th term, so we expect 4d, as you can see there, is this. And they're saying the 8th term, so we expect 7d is this. Respectively. And I assure you, this is where series stop. Hey. You people, where series stop is saying 3rd term, you put here to 5th term, put there for 8th term, put there 7. Now the rest is algebra, because they're asking for the value of x and the value of common difference, which is d. So I don't want you to say I never taught the topic. I've taught the topic and you now know 3rd term we expect 2d somewhere, 5th term we expect 4d, and 8th term we expect 7d. You get? A. Period. Period. Okay. Now, I don't know what really people want me to do. But if I told your people who have been studying solving equations, I don't think really this can give you hard time. If your people who studied how to solve an equation having 3 unknowns, I don't think you can get issues. Because that's where series stop. These other things coming down, it is just normal algebra. Because you can see, now here I'm going to just request people. The good thing I will send notes. Here people will just follow up. It is. You see, I always want to leave here with a lot of tasks. So that you people understand that the years are only 2, but with a lot of tasks. That's why very few people always pass a level, because it needs endurance and perseverance. I'm telling you facts. So I want you to sit down, analyze this statement, subtracting 1 from 2, subtracting 1 from 3, subtracting, they are saying substituting 4 into 5. These are equations you've been solving for even at O level. You get? Let me ask, do I have anyone who can follow up and fail to understand? You people, you can see that throughout here you have A. So elimination method can work. Just keep on eliminating that A. Then you remain with the equations that are in D and X. Can you fail to solve simultaneous equations with only D and X? You see, they subtracted 1 from 2, then they subtracted 1 from 3, just to eliminate A, so that they remain with 2 equations in D and X. Can you fail to solve for 2 equations in D and X? So I want to see 5 people in the comment section saying, I can solve, I can solve. saying I can solve, I can solve, I can solve. I want 3 people saying I can solve, I can solve, I can solve. So roots of cubic equations, this one is another topic, unknown series. This is another topic that is, of course, the topic is called roots of quadratic and cubic equations. But if there are those people who attended my lesson on polynomials, you can read something from here and get, trust me. Someone is like, I can use substitution. I can solve, I can solve. Hey, you people don't just say you can solve, please. You need to take your time. Hey, you see, I think this, they are using it again. So this one will be very obvious. You can literally follow up. Exercise has reached. And you know what exercise means. So this question, you go through it because these terms I warned you. Now, this one is involving roots, which is another topic. But if you attended polynomials, you very well know me. I don't repeat myself. That's why I always encourage you to make my notes from the video lessons, so that when I make a statement and say refer to this, you can literally refer very fast. So, after exercise, the next thing you can see, it is GP. And the timetable was very clear that the lesson I shifted tonight, which we are supposed to do in the morning, had the word GP. And when you look at the time, had the word A.P. And when you look at the timetable, the next lesson we are supposed to have, it is for GP. And I'll come here, we do GP. I didn't want to do them at once because you could confuse. But I just gave an introduction. These things of common ratio, you even know geometrical mean. I said those words. So when I come back, things will be a bit easier. But trust me, we shall be going through the same thing. I'll waste a lot of time on introduction, a lot of time. Then I reach examples, I just start hurting you psychologically. So all these exercises are full of computation tasks, which are the roots to scenarios. The moment these ones make total sense, scenarios will be the easiest. So you take that screenshot first, then you take the other one last. So you should post this assignment in the discussion group. Yes, you should post it in the discussion group. After that, you take that one too. She will send a very clear screenshot. She's good at that. Then the other thing we have been using, try it in. I think I'm going to share it after here. Yeah, so you ask for it. So those who have a very keen eyesight, you can see that this is where we shall begin from. And we're on page 8 of 17. So as usual, our first lesson, we have managed to cover what? 50%. And that's what we always do. Yes. If we manage to cover 100%, well and good. If we don't, two lessons, we are done. Two lessons done. Two lessons, we are done. If it is very long, like topics of integration, we take a full term, can have a week. But those topics are already there on the drive of senior 6. I'll never teach them again. Yeah. So that is it. 50% was covered. So I think we shall meet next time, unless someone has a concern. But thank you for staying on. So can sign out. Can sign out. So our next thing is GPA. So we have respected the timetable, and for the first time we have ended at midnight, exactly midnight. So our website is there to access more services. mathonline.com. Reaching out to me is that via WhatsApp call. Thanks for attending. And so I really need someone to give us yesterday Eric gave a very good prayer. Eric, are you on? Yeah, quick recovery. I'm going to get recovered. Alice, you can use any method you want. Eric, are you on? Raise up your hand to pray for us. Yesterday you gave a very good prayer. Or anyone ready to give us a closing prayer to bless our day? So even when you just check in the syllabus book, yeah, trust me, we have done it. We've done it. Yeah, all things here done. Whatever you see here. These things of applications, they are just there to show you how the scenarios will look like. So if your neighbor wakes up and wants to set for a scenario on series, it will set on investment growth and payment schemes. But you can also make applications. You can make research on these applications. That is your work. But derivations, all those things we have done. Yeah, literally the next thing is geometric progression. Yeah. Yes, Eric, unmute and pray.
Okay, good morning to everybody. Let's humble ourselves and have the prayer. My Father, we thank you for this day. Thank you for the gift of life. We thank you that we have covered another 50% again today. Lord Father, we know that we've not grasped everything, but as we are going to pass through it again in our days, Lord, enable us that we understand and get everything while our teachers will be teaching, that we may teach our fellows, that we may show that we grasped something, Father. Lord, you provide every person with the knowledge necessary. Lord, heal our teacher, Father, because without him, we can't be anywhere. Provide us with all the necessities. Bless our nights. Provide him with $1,000,000 again and again. In Jesus' name I've prayed.
Amen. Yes, thank you so much, Eric, for the prayer. Yeah, I think people can have a good night. Yeah, I want to see you try some numbers, you people, before you sleep, around 5. So I want to see 5 images being posted as solutions to some numbers of the assignments. Yeah, then I comment a bit. Then we end the night peacefully. Otherwise, thanks for attending.